A warm welcome and very good evening to all dear participants. Resource person of today's session, our respected Dr. Dharmendra Kumar Yadav sir. Today, we are having our session on measure of variability. Now, I would like to introduce today's resource person of the session, Dr. Dharmendra Kumar Yadav sir. Sir is presently working as an assistant professor at Department of Statistics and Demography, National Institute of Health and Family Welfare, New Delhi. Sir is Assistant Nodal Officer of Learning Management Information System, a digital learning initiative by Ministry of Health and Family Welfare and former Nodal Officer of the Center for Health Informatics, Ministry of Health and Family Welfare, Government of India. He is the Fellow of Royal Statistical Society, London, UK, and elected member of International Statistical Institute, Netherlands. His fields of specialization are artificial intelligence, machine learning, health informatics, digital health, and sampling theory. He has 40 research publications in various journals of national and international repute. He has been the editor of 10 edited books and contributed 20 chapters to various books. Dr. Yadav sir is the author of two popular books on Digital Health in India, Evolution of Health, Informatics and Artificial Intelligence, and Machine Learning in Healthcare. Dr. Yadav sir is a member of many professional bodies, including Indian Society for Medical Statistics, Biostatistics Consortium, International Biometric Society, and Indian Statistical Institute, Kolkata. He is also associated with the research projects of Ministry of Health and Family Welfare, Indian Council of Medical Research, and UNESCO. Dr. Yadav sir has received Research Excellence Award 2020 by Institute of Scholars, Bangalore. Excellent Presentation Award at FIM International Conference 2021 at Waseda University, Japan. And Best Paper Award at International Conference 2022 by American Institute of Management and Technology, University of Maryland, Eastern Shore, USA. Now, I would like to invite sir to kindly lead today's session on a measure of variability. Please, sir, welcome, sir.
Thank you, Dr. Amit, for your nice words. And thanks to organizers for giving me this opportunity to interact with all the participants who are, joining this 3-month certificate course. So thank you so much. So what the responsibility is given to me to give the brief idea about very basic fundamentals of you can say that the uh, of statistics. So I will try to give my best because many of the participants are from I think non-statistics background. So I will try to make my session simple and easy to understand. So okay, so let me share my screen. Is it visible?
Yes, sir, visible now. Make it in slideshow mode.
Yeah, I think it's fine now. Just give me the 1 minute. Yeah, is it fine now?
Yes, visible now, sir.
Okay, so very good evening to all the participants. So first of all, I will try to give some basic idea about the descriptive statistics, and we will cover the basic concepts which are covered in the descriptive statistics. So as we all know that there are broadly we can classify the whole statistics into two branches. One is descriptive statistics and another is inferential statistics. So I think inferential statistics part has been covered by various previous speakers, so I will not go into that. So as we know that descriptive statistics is nothing, only a broad description about the data set, what the data set we have. So before applying any statistical test or any statistical method on the data set, we just give the, do the broad data diagnosis. Okay, see, it's just like a, suppose I'm working in the medical field. So if any medical, if you are a doctor and any patient come to you, Then before giving any prescription or medicine, you just write some basic diagnosis. Okay, so just go for the hemoglobin level, check your BP level, sugar level, and so many diagnosis, medical diagnosis will be done. So in the same way, before applying any statistical test on the data set, we just go for the data diagnosis. Okay, what is the nature of your data, whether it is normal or not, whether it is skewed or not, so whether it is following the satisfying the basic assumption of normality or not. So we will go and check about the nature of data. Okay, so nothing additional can be done on this descriptive statistics. So such statistics which gives the summary about the data set, brief summary, that what is the name. Just like if you anybody ask your description, then you will say your name, what is your name, what is your gender, what is your you know age, and what is your qualification. So in that similar pattern, in before applying any data analysis, we just go for the brief description about the data set. That is called descriptive statistics, and it doesn't provide any evidence for the future prediction or future purpose. We cannot do any further future analysis with the help of descriptive statistics. So basic descriptive statistics covers these four aspects. There are four basic descriptive statistics. One is measure of central tendency, measure of dispersion, skewness, and kurtosis. So these all four comes under the data diagnosis part or basic descriptive statistics. So as we all know that measure of central tendency, so this measure of central tendency has why it is called central tendency. Because as we know that all the data in any data set, all the data, all the observations has a tendency to you know come or concentrate about a particular central value or average value. So that's why this central tendency also called the average value. So we will find the average value towards each observation wants to concentrate. That's why this is called measure of central tendency. And the other one is measure of dispersion. Dispersion means deviation. It means how your data, each observation, how your data is deviated towards from a particular average value. Okay, so dispersion means those measure of dispersion. Dispersion means what there is a particular central value or average value, and in the measure of dispersion, we will try to identify or we try to measure how your data is dispersed towards a particular average value. Okay, so we have
Sir,
certain average value, and
please
with the
move the slide. Sorry to interrupt, sir. Please move the slide.
yes,
Uh,
I'm not moving. I'm
yeah.
just
Okay.
explaining.
Okay.
I'm just
Okay, sir.
explaining what are the basic descriptive statistics. So central tendency has a tendency to, each observation has a tendency to move or concentrate towards a particular value, that is called central tendency. The second measure is dispersion. It means each observation we will try to understand that how each observation is deviating from a particular central value. Okay, that is the skewness, like this one, variance, mean deviation, standard deviation, and other things. So similarly, skewness is nothing. It shows the distribution of your probability distribution of your data. It means it tells us the lack of symmetry, how your data is uh, you know associated with the probabilities. It means there is any, if there any lack of symmetry, or your data is normal or not. As we all know that our data is, if it is normal, then it is a bell shaped. If mean, median, all the average values lies on the same point. And the another one is kurtosis. So kurtosis is basically, it is about the peakedness of your curve. So these all are called, four called descriptive statistics. Then the another part is inferential statistics. So inferential statistics is nothing. What the data we have, on the basis of that data or that information, we are try to give the inference or certain evidences for the future purpose. So that's called inferential statistics. So It covered the estimation and testing of hypothesis. So I will not go into that. So I will cover basically this descriptive statistics part. So measure of central tendency, as I have mentioned that measure of central tendency means because we all know that data set contains many variables. Okay, so every variable has many observations, definitely. Suppose we have two variables, that is age and height of the students. Then we have two variables, age and height, and both the variables has different observations. So it is not possible, it is very difficult to handle each observations and dig out the information from every observation. Suppose we are giving the uh, you know age and gender, sorry, age and height or age and weight of the students, then these are only the observations. So we cannot predict or we cannot get any information from these observations. So we are trying to summarize it. So our interest is in summary of information which is hidden inside the data. It means we have a height observations on the height of 10 students in a class. So what we are in which we are interested to find out what is the average height of your student, of these 10 students. So another way around, we are interested to find out the central tendency, that but which at which particular value our these 10 observations are you know moving or concentrated. So that's why these are called measure of central tendency. So measure of central tendency tells us that around which particular central value our whole observations are concentrated. So this is the basic concept of central tendency. So for example, suppose that the last year's temperature, which is in centigrade, of the following two cities, one is Lucknow, another is Srinagar. So what type of clothing are required needed to visit these two cities in the month of May? Suppose, so what the prediction, what statistically statistical information can we do from these observations? Okay, so what we can do, we can find out the average temperature of both the cities, Lucknow as well as Srinagar. Then whose average temperature is, accordingly we will find out that whether clothing, which type of clothing is required in the month of May on the basis of average temperature. Because we cannot say that on the basis of these observations we cannot make any inference or we cannot make any decision. That's why these measures of central tendency are required. So that's why this natural human tendency is to compile the information in terms of average. What are the average marks of your students? What is the average temperature of any particular place? So, for example, the average marks in a subject in a class are 60%. A medicine tablet controls the fever for the 6 hours. So, a statistical concept refers to the average or the central of the data, central tendency of the data. So that's why we are more interested into the central tendency, measure of central tendency, because independent observations cannot give the real picture. That's why we are interested into the central tendency. So in statistics, we have different types of measure of central tendency. We have mean, median, and mode. Okay, so mean generally is associated with, or we can say that it is arithmetic mean, but there are other means also, that is geometric and harmonic means are also a part of this measure of central tendency. Median is another central tendency, and quantiles and mode. So these are called measure of central tendency. Okay, so I will not go into much detail, but I will tell you because arithmetic mean, there are different types of different types of observations are given. So in that case we will find out the arithmetic mean for each case. Okay, suppose our data is given in the ungrouped form. Ungrouped means there is no categorization of the data. We have the data in the bulk. Okay, there are suppose n observations are given or 10 observations are given and we are not categorizing it. That's why this is called ungrouped data. So for that we calculate the arithmetic mean by using the formula that we will total or sum of all the observations divided by number of observations. Okay, so summation of xi, because all the observations are x1, x2, xn, there are n observations, so we will sum up all the observations and then divide whole the observations divided by the number of observations. Then in that way we can calculate the arithmetic mean for the ungrouped data. It means only observations are given. But the another case may be if your data is grouped. If your data is grouped means you are categorizing your data into different categories. Okay, it means at which particular data is occurring which particular of time. It means your observations as well as frequencies are also given. So in that case, the formula may be different. That is 1 upon capital N summation of fi xi. So we will multiply xi, it means observations, with the frequencies and then divide by the total sum of frequencies for the group data. So I will not go into that. So this is the basic concept of arithmetic mean. Similarly, geometric mean and harmonic mean is also there. So I will give a one example where arithmetic mean is important. So I will give you example where this arithmetic is more appropriate. Okay, so arithmetic mean is simplest one, but at the same time, and it has some drawbacks also. And the drawback is that it is highly affected by the outliers. Okay, so what are the outliers or extreme values? What are the outliers? So you can write in the chat box also. What are the outliers? And these all observations or these arithmetic mean is highly affected by the outliers. This is the drawback. Suppose we have a data of income, then your income may be different or it can be have some outliers or extreme values. So this arithmetic mean will not give you the real picture. That's why this is the basic drawback of this arithmetic mean. Is it okay? So Amit, can you hear me?
Yes, sir. Yes, sir.
So okay. So can we make it interaction or only one way communication is there?
Yes, interactions, sir. Someone replied on the chat box, Dr. Harni away from mean, and someone replied the extreme values.
Okay, that's good. That's good. So this is the extreme values. It is affected by the extreme values. So in that case, if your data has extreme values or outliers, then this arithmetic mean is not recommended. Okay. So the another variable, another measure of central tendency is geometric mean and harmonic mean. So what is geometric mean, and when this is used? Because I think only to know the statistical technique is not good enough. You must know in which category or which situation which central tendency will be used. That is very important part. So when this arithmetic mean is used, when your data is very simple and they don't have any outlier, then arithmetic mean is used to find out the average. Then if your data has outlier, then arithmetic mean is not preferable. So the another case is geometric mean. So when this geometric mean is used, so this geometric mean is useful in calculating the average value of ratio or rate of interest. Okay, if it means if you are interested to find out the ratio or rate of interest, or generally we are using it in the index number. At the time of find out the index number, formulating the index number or rate of interest, then we go for the average rate of interest, average ratio, then we go for the geometric mean. Okay, but this geometric mean is not applicable if any observation is zero. This is the drawback of this geometric mean. And what is the formula for geometric mean? So if all the observations are not positive, Then we will calculate the geometric mean by using this formula. That means we will calculate it, we will multiply all the observations. Then we find out the root of nth root of that observation. It means if we have only two observations, it means x1 into x2 whole to the power 1 by 2. It means square root of these two observations will give the geometric mean. Similarly, if we have three observations, then cube root of this all these three observations will give the geometric mean. So in that way, if we have n observations, then nth root of these observations gives the geometric mean. Okay, so the basic concept was, when we use the geometric mean, if for your data, if you are interested to calculate the ratio or rate of interest, and when we will not use the geometric mean if any observation is zero. Okay, and this is the formula. We will find out the just nth root of the observation, that will give the geometric mean, right? So this is the another formula. It means if we have group data means it is categorized. If we have class intervals, then what we will do, the class interval is given and the frequencies are given. Then we will find out the midpoints, the lower limit plus upper limit divided by 2. So that will give the observations. So we will calculate it by using this formula. So I will not go into the formula. So this is the example. Class intervals are given and then frequencies are given. Then we will calculate the geometric mean. The another important, this central tendency is mean is harmonic mean. So when we go for the harmonic mean, if we are calculating the average, okay, and this is the average is nothing, only the ratio of two observations, and both the observations have different types of relationship. It means reciprocal type. If one thing is increasing, the another will be decreasing. So in that case, we go for the harmonic mean. Then what is the formula for harmonic mean? So for what we can do, we have x1, x2, xn, n observations. Then what we do, we just find out the reciprocal of all the observations. 1 upon x1, 1 upon x2, and 1 upon xn, right? After that, we will calculate the mean of all these reciprocals. It means 1 upon n summation of 1 upon xi. What will come? We will find out
Sir,
the.
slides are not changing.
No problem, ma'am. I'm not changing yet. I'm just explaining the formula.
Okay, because
These are changing or not?
Not changing, sir. Not changing right now.
Okay, sorry for that.
No, changing, sir.
Hmm. Okay, whether it is changing or not?
Now we are on seventh slide.
Okay, we are on the seventh slide.
Now this is it. Seventh.
Okay, so is it visible now?
Yes.
Okay, so this is the formula for the harmonic mean. It means we will first, these observations are given like 1, 2, 3, 4, 5. These 5 observations are given. Then we will find out the reciprocal of all the observations. 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5. Okay. Then we will find out the arithmetic mean of all these reciprocals. It means 1 upon 5 into summation of 1 upon these observations. 1 plus 1 by 2 plus 1 by 3 and so on. Then what will come? Suppose it comes out to be 2.5. Then 1 upon, we will just reciprocate, okay, reverse of all these mean, arithmetic mean. Then it means 1 upon 2.5. That will be called the harmonic mean. Okay. So can anybody tell me the relationship between these arithmetic mean, geometric mean, harmonic mean? What is the relationship between these arithmetic, geometric, and harmonic? There
Please
is a
reply in the chat box or raise your hand so I can send you the unmute request. I request to all participants.
so no problem. So there is a relationship between arithmetic, geometric, and harmonic, that is AH is equal to G square. A is our arithmetic mean, H is our harmonic mean, and G is the geometric mean. So AH is equal to G square, or G is equal square root of A into H, right? So this is the relationship. Then the another, so this is all the relationship, like this is the formula. So I will share this PPT. So now I'm moving towards the median. This is another one. So what is median? Another measure of central tendency. So this measure of central tendency is median. And when this median is used, and what is median? So median is that, you can say that particular value or average which divides whole observations or whole data set into two equal parts, right? So this is called median. It means half observations will be greater than that particular value and half will be the lesser of that particular value. And when this median is used, I have told you that if your extreme observations are present in the data set, then arithmetic mean will not give the real picture, right? So what is the alternative? So in that case, we go for the median. It means when your data set had extreme values or these outliers, so in that case, we go for the median instead of arithmetic mean. This is the first case, and the second case is if your observations have qualitative in nature. It means they are not expressible in the form of numbers, like qualitative data. If you have qualitative data, so in that case, suppose I'm just want to know what is the average, IQ level of all these participants, okay, or who is the most, smart student in this class. So we cannot go for the arithmetic mean or geometric or harmonic. So in that case, we go for the median. So median is used in two cases. Number one, when our data set has extreme values or outliers, and the second, if your data set is qualitative in nature, right? So in these two cases, we go for the median. So how we calculate the median? So first we divide the whole, part into two equal, like first we arrange the data set into two. So how we calculate the median?
Many
Suppose,
participants are replying in the chat box, sir.
okay, okay, great. So first okay, suppose we have three observations or four observations. I'm just writing here, 1, 2, 5, 4, 3. Okay. So
Sir,
suppose we,
it's not visible. Are you sharing anything with us, sir?
uh, These observations are given. Okay.
There is
So
nothing visible. There is nothing visible to us.
okay, just a minute.
The
Maybe I have
screen is
not.
not sharing.
Yeah, I have to share the screen right now.
Yes.
Just a minute. Okay, so is it visible?
Yes, yes, visible, sir.
So suppose we have these two, five observations, 1, 2, 5, 4, 3. Okay, so how you will calculate the median? We have, this is the ungrouped data. So what we do, we first either arrange these observations into ascending or descending order. After that, we will calculate the median by using the formula that if your observations are odd, there are two cases. If number of observations are even or odd, right? So if your observations are even, then if your observations are odd, okay. Suppose these are the five numbers, five observations. So this is the odd number. So how you will calculate the median? N plus 1 by 2h term. Here, this is the not number, not the value. Here, this is the positional average. It means the number, the observation which lies on this particular point, that will be our median. So first we arrange the data into different ascending or descending order. So what will the ascending order? 1, 2, 3, 4, 5, right? Then n plus 1 by 2th term. It means n means, just a minute. So how you will calculate? Can you tell me the answer? Median is your 3, right? So what is the value? So 3 will be the value, right? And if these are suppose only 4 observations, then what is the value? Please tell me. Suppose we have only 1, 2, 3, 4, 4 values. They are 1, 2, 4, 5. Then what will be the median? Then average of middle of two observations. This means the formula will be n by 2s term plus n by 2 plus 1s term divided by 2. So extreme observations, we will middle most values and then we take the average of that. It means 1, 2, 4, 5. We will write then n by 2s term. It means second term plus third term, then divided by 2, right? So what is the second term? 2 plus 4, 6, 6, and then divided by 2. So what will be the median? 3. Yes, right. A. Ramakrishna, you are right. So everyone who is giving the answer 3 is right. So this is the way how you will calculate the median. So the another important measure of central tendency is mode. And what is the mode? Is it visible, Amit?
Yes, sir. Visible now.
Okay, so what is the mode? Can you tell me what is the mode and when it is used?
Most participants replied most frequent number, most observed
Yeah,
value.
great, great. It means if we have the observations, so mode is that particular value which has the highest frequency among the other observations. Okay, so and when it is used, what is the utility of this mode? Suppose I am a shopkeeper and okay, I am selling the fruit. So what is my purpose? I want to know that which particular fruit is more popular. Okay, which particular fruit juice is more popular among the customers. So for that, I am interested in the frequency. It means number of frequency whose fruit juice is frequency is highest. It means that is more popular. So that will give you the. So as a shopkeeper, my interest is in the mode. I'm not interested in the average. What is the average sale? Okay, what is the median sale? My interest is to in the mode value. Okay, suppose I'm a shopkeeper. I'm selling the different types of clothes or different model or different this different types of clothes brand the different brands of clothes. Then I'm interested that which particular brand is in the trend. So how you will calculate, how you will find out? By using the mode value. Okay, so we will find out that which what is the frequency whose frequency is highest, so that that particular product is trend that in the you know market. So accordingly I will make my this stock. So in that case mode give the real picture. Suppose a fruit juice shop owner wants to know that which of the fruit juice is more preferred, or clothing shop owner wants to know which size of shirt and trouser is highest in the demand. So how you will check? By using the mod value. You will calculate that whose frequency is highest, that is it means that is more preferred, right? So mod of n observations, suppose we have n observations, x1 x2 xn is the value which occurs the most compared with the other values. So in that case we use the mod value. So mod is the value which occurs most frequently in a set of observations, and mod is not at all affected by the extreme observations. So different distributions having only one mode are called unimodal, and the one with the two mode, because it may be the unimodal or bimodal. More than one mode also can be picture. More than one mode will be there sometimes. So for the discrete variables, so you have any idea about the discrete and continuous variable? What is discrete and what is continuous? You can write in the chat box what is discrete variable. So discrete variable or continuous variable. Discrete is free from another. Okay. Discrete means whole number, no specific pattern. Okay. So I'm just giving you a simple example. Discrete is for qualitative and continuous for quantitative. Okay, Silpa Shukla, it may be the one reason. But suppose I am a layman, okay, I don't have any idea. So how you will tell me that which is continuous and which is discrete variable? Okay. So I'm giving you very simplest definition that what is continuous. So continuous can take any possible value within a given interval. Okay, suppose I am giving you example that the average age, okay, of this observe this particular group of these participants, or the lies between 20 years to 40 years, or 20 years to 50 years. Okay, this is the average age of participants of this group. So whether it is a discrete or continuous, it is a continuous because it can take all the possible values from between 20 to 40. It can take 21 also, it can take 39 point or 59 50 49.9 also. Okay, so continuous can take all the possible values within a given interval. Okay, it may be it has some fractional values also, but discrete values are always take the integer values. They cannot take the fractional values. Okay, like what are the number of students in a class? Okay, what is the number of patients in a hospital? So it can always has the whole number, integer values. Okay, so continuous can take all the possible values. It may be the fractional also, right? So for the discrete variables, what we do? We calculate the mode. So for discrete variables, the mode of variable is the value of variable having the highest frequency in a unimodal distribution. So for the continuous variable, is it visible? So mode for the group data. So for continuous variable, the mode is the value of the variable with the highest frequency density corresponding to the ideal distribution, which would be obtained if the total frequency were increased indefinitely, and if at the same time the width of the class intervals were decreased indefinitely. It means for the group data or continuous data, the mod is the value of the variable with the highest frequency density, okay, to the ideal distribution, which would be obtained if the total frequency were increased indefinitely. अगर इंक्रीज आपकी फ्रीक्वेंसी बढ़ाई जा रही है और इसकी जो क्लास इंटरवल्स है वो डिक्रीज की जा रही है, तो उस केस में क्या होगा? आपका जो हाईएस्ट फ्रीक्वेंसी डेंसिटी होती है, दैट इज कॉल्ड मॉड वैल्यू. So here we will find out the model class, not the particular mod value. Okay, so the class corresponding to the maximum frequency is called model class, right? So class intervals we have midpoints, absolute frequency is there. Then we will check that that particular class which has the highest frequency, that is called model class. Then using this formula, we will calculate the mod value for the group data, right? So suppose this is the data set. Taken a customer to arrive in a shop in a month on different days are recorded, 1 to 31 days. Then we will check what is the mod value. So frequency we will calculate. So whose frequency is highest, that is called mod value, right? So quantile is nothing, only the special case of this your general case of median. Like what is the 25% quantiles or 50% quantile? So this 50% quantile is also called a median because it divides the whole data set into two equal parts, 50%, right? So this is the measure of central tendency. Now, the another measure of, you can say the descriptive statistics is measure of dispersion, right? So what is the measure of dispersion? And why it is called dispersion or variability, you can say that measure of variability also. Amit, is it visible?
Yes, sir.
Okay.
Visible, sir.
So variation in the data or measurement of variability. So in measure of central tendency, we are interested more into that how your data is, concentrated towards a particular central value, average value. We are interested into the average value. That's why mean, median, mode, they all are associated with the average, okay, or middlemost value. We are interested that around which particular central value our whole data set is concentrated. But in measure of variability or measure of dispersion, we are interested into what? We are interested to find out that how your data is deviated or dispersed towards a central value, or from this central value, that how your data or all the observations are deviated from your average value. There is an average value in central tendency. Now we will check that which particular observation or which particular data is deviating from that particular value, average value. That's why this is called measure of variability, right? Or variation in the data. Measure of variability or measure of dispersion, you can say. So if we are testing for our like real life example, suppose I am just saying that how I am, you know, different from other. Okay. So how you will calculate the variability, measurement of variability? You have to standardize one observation, and we will check how you are deviating, how you are different from that particular standard value, and that particular standard value is called average value. Okay, so we will check that how this particular observation is different from mean value or median value, something like that. So measure of variation or measure of dispersion is nothing. It gives the, because as we know that measure of central tendency gives an idea about the location where most of the data is concentrated. Okay, suppose I am giving an example that what is the average age of this group of participants. So after calculating all these values, we will find out that the average age of this group is 25 or 30 years. So 30-year, this is called central value or measure of central tendency, average value. Now we will check that which particular value is deviating from this 30. That is called dispersion, right? So where the measure of central tendency gives the idea about the location or particular value where most of the data is concentrated. That is called central tendency or central value. But two different data sets may have same arithmetic mean, but they may have different concentrations around the mean, right? So we are more interested to find out the variation or dispersion. And I must say, as a statistician, that all the statistics lies towards this variability. If variability will be not there, there is no use of statistics. So all the statistical methods, all the statistical tests, they all are used to know the difference or variation or dispersion. Okay, what we do in the t-test, we find out if there is a significant difference or not, right? So we are interested into the significant difference. So all the statistics lies on only this particular point, whether your one data is different from other or not. That's why we are interested to check whether data is significantly different or not. Okay, whether it is significantly different from mean or not, significantly different two groups are different or not. So all the statistical tests are based to find out this dispersion or variability, right? So simply, central tendency measures that around which particular value our whole data set is concentrated. That's why it's called central tendency. And the deviation or measure of dispersion measures how all the observations are deviating from a particular central value. Okay, this is called dispersion or variation. So what this is the temperature of three cities from day 1 to day 6. And then what is the variability? City 1, day 1, day 2, day 3, all they have same temperature. So is there variability? No. So arithmetic mean of the city 1 is 0. So we are calculating the arithmetic mean of all these cities temperature. Then city 2 temperature will be 0. Then city 3 has the arithmetic mean of 10. Now we'll check city 1 and city 2. Both the cities have 0 arithmetic mean. So what can we do? What can we say that the average temperature of city 1 and city 2 is 0, although
So
it is
please,
arithmetic
please,
mean is 0 for both the cases, both the city. But here we can see that this is the day 1 minus 50-degree temperature, day 2 minus 50, minus 3, minus 15, and then 15, 15 like this. So can we say that the average temperature of city 2 is 0? Is it so?
so please move slide.
Is it moving?
No, sir, no, sir. We are
Okay.
on first slide. Now visible, sir.
Okay, so okay, right. So so I'm just giving you example that why this measure of dispersion or variation is required. Okay. The arithmetic mean of two data set may be same. For example, there is a data of three cities temperature for these 6 days, right? So in city 1, all the observations, all the data of temperature is 0. Okay. Then city 2 minus 15, day 2 has minus 15, day 3 is minus 15, day 4 is 15, 15, 15. So arithmetic mean of city 1 and city 2, both the cities is 0. So can we say that the average temperature of city 2 is 0? Yes or no? Please write in the chat box. Can we say no? Why? Because the arithmetic mean is 0. So average temperature is 0. So So mean temperature of city 1 2 are same 0, but doesn't make any sense? No. Why? Because city 2 has two extreme temperature, minus 15 and 15. Then city 3 has the variation among the values. So which temperature is more reliable? City 3 or city 1 or 2? So those data set which has the variability, that makes sense. If your data is not having any variability, then it will not give the real picture. That's why this variation or dispersion is required, because the arithmetic mean may be same of two data set, but if there is no variability, then it will not give the real picture. For example, this is the data set, this is the graphical representation, this is the temperature in city 1, temperature is constant. Okay, this temperature in city 2, these are the outliers. These three are outliers, minus 15 or 5 plus 15, only two observations. But the city 3 has all the data set is surrounded towards a all around, this is dispersed. You can say that their data is dispersed. They are not concentrated towards a particular value, right? So for the policy making or for the decision making, which data is used? Which data is better? City 3 data. That will be better. Now, so these center tendency or measure of center tendency are called the location measures, but they are not enough to describe the behavior of the data. What is the behavior of data? So, concentration or dispersion of observations around any particular value is another property to characterize the data, right? So, how to capture this variation? It means there are different measures of variation or measure of dispersion also, instead of measure of center tendency. And what are these measures? These are some examples that if you have two data sets, one is green and another is red dots, then same mean of red and green colored data points. So whose variation is more? Which data is more dispersed? Which data is more concentrated around mean? Because this mean is the central value. Okay, so that data which has the more dispersed, we will check that how these data are dispersed from mean. So this spread and scatteredness of data can be measured around any point, but the mean value is more preferred. Why? Why this mean value is preferred? Because the deviation from arithmetic mean is always 0. That's why this mean is preferred. We will take the deviation. Okay, so there are different types of measure of variation, measure of dispersion. Okay, some measures are based on range and quartiles. So there are different measures of variation or dispersion: range, interquartile range, quartile deviation, absolute mean deviation, variance, standard deviation. So these are called measure of dispersion or variation. So what is range? Suppose we have 5 observations, 1, 2, 3, 4, 5. Then how you will calculate the range? So range is nothing, only the difference between the maximum and minimum value of the data, right? So R is equal to maximum of all the observations x1, x2, xn minus minimum of the observations. Suppose I have the data set 1, 2, 3, 4, 5. Then what will be the range? 5 minus 1. It means maximum value minus minimum value. That is called range. So this is the one measure of dispersion. And then range, the data set having the higher value of range has more variability, because range, if this range is higher, it means high, then it is not, because that has more variability. For example, suppose I am saying that the average age of the participants lies between 20 to 30. Is it right? Or I can say that from 20 to 50. Which statement is more good? Because whose variability is higher? 20 to 50. The 20 to 30 will be preferred. Okay. So whose that particular data which has the lower value of range, that will be preferred. Right? So less variability is always preferred. So the another important measure of dispersion is interquartile range. Okay. So interquartile range is the third quartile, difference between third quartile minus first quartile. And what is this quartile? Quartile means quarter. It means the data which divides whole data set into four equal parts. So what is the Q3? Third quartile, which divide the whole data set into, that is a 75%. And what is the Q1? That is 25%. So 75 minus 25%. It means it covers the distribution and contains 50% of the observations. Right? So this is the interquartile range. And what is the decision making? The data set having the higher value of interquartile range has the more variability. Same case in the range. So range, the data which has the lesser range will be preferred because that has the lesser variability. There is another is a quartile deviation. So quartile deviation, that is based on the interquartile range. So just we find out the Q3 minus Q1 by 2. That is interquartile range divided by 2. That is called quartile deviation. So first we calculate the interquartile range, that is Q3 minus Q1, then divided by 2. That is called quartile deviation. Then some measure of variability or measure of dispersions which are absolute. It means there is no difference type of thing. It means because these are the relative Q3 minus Q1. This is the relative change. So this,
So please change the slides.
yes, please. I'm just checking. So is it visible?
Yes.
So there are some variables, some measure of dispersion which are not based on difference or they are called relative changes. But now there are some absolute deviations. Those measure of variations which are based on absolute deviations. So range, interquartile range, is it visible? My slides are changing or not?
Yeah, on 17th slide. We are on 17th slide.
Okay, sorry.
Yeah, now visible, sir.
It
18.
is fine. It's fine.
Yes, on 18th.
Okay.
Deviation based measure of variation.
Okay. So this deviation based on the measure of variation, it means range, interquartile range, and quartile deviation. They all are based on the certain ranges. Okay. It means there are relative changes. If we will change Q3, then whole value will be changed. Okay, that's why they are not called absolute deviation. So for that, we need a measure which can measure the deviation of every observation around a given value. Then, so which are based on the measure of variation. So deviation of any observations xi, that is there is observation from any value a, and this a is the extended one. Now we will check that how the observations xi is deviating from a standard value a, right? And this standard value a may be the mean or median or anything. So if xi minus a, it means this difference or deviation, if xi is greater than a, it means if your difference is positive, or it may be negative, or if it is zero, it means there is no difference. Deviation is not, there is no difference, no deviation. So if we consider the average of these observations, then the average value may be close to zero or will be reflecting there is no variation or small variations, which may not be correct. So we need not to consider the sign of the deviation. Okay, because this deviation may be negative or positive, right? This deviation di is greater than or less than 0 if it is negative or positive. But we have to avoid this type of this sign of this this variation, deviation, negative or positive sign. So for that we go for the magnitudes of the deviation. Magnitudes means we will take the absolute deviation. Absolute means modulus value, mod value. There are two options. Either we consider the absolute values of these deviations or we consider the square values of these. Okay, absolute means modulus value of this deviation, or we can use the squared values of these deviations. There are two options, right? So there are some deviations, measure of deviations, right? So this is the data set, class intervals, and then midpoints, absolute frequencies. Now there is the absolute deviation. Absolute deviation means we have the absolute deviation around a particular value A. Okay, and this is the particular value A, and this is deviation, that is 1 upon small n summation of mod of xi minus A. That's why we are using here modulus value. Why? To avoid the sign of this difference or deviation. Now, is it changing or not? Absolute mean deviation. So what is absolute mean deviation? The absolute deviation of observations is minimum when measured around the median. And here A is nothing, only the median value. What the A is, I have shown you here. And here A is a any particular, any specific value. Okay. This is the any particular value A. We are taking the deviation from any particular value A. But this deviation is minimum when it is taken as median. A is taken as median. Here A is the median value and it is minimum. Okay, so this is called absolute mean deviation. And what is the difference? This is the definition, this is the formula for the absolute mean deviation. It means absolute mean deviation is that particular value or deviation if it is taken from the median, right? So absolute mean deviation measures the spread and scatteredness of the data around, preferably the median value, in terms of absolute deviations. So this is the definition of absolute mean deviation. So what is the decision making? It means which type of absolute mean deviation is preferred. The data set having the higher value of absolute mean deviation has more variability, and the data set which has the lower value of absolute, that is preferred. So a data set which has always the lesser measure of dispersion has been preferred. So this is the one example or one method. The another method is for the group data. Now the data which is based on squares, because we have there are two options for you know avoiding the sign of this data set, sign of deviation. So another one example was either we take the modulus value or absolute deviation. The another method was to take the square of that deviation. Okay, so what is the mean square error? If we are taking the absolute deviation, not taking the absolute deviation, but we are taking the square values of the deviation. Okay, it means we are considering the square of this deviation, xi minus a whole square, right? So the mean square error with respect to a is defined as 1 upon n summation of xi minus a whole square. For the ungrouped data, you can say that for the group it will be frequency will be there. So this is called mean square error. Here we are not using the term mean square deviation, but here we are using the mean square error. Then there are some other measure of variability also. Okay, Amit, is it visible?
Yes, sir. Yes, sir.
Okay, so this is the mean squared error. It means we are squaring the deviation, right? Then there is a very popular measure of dispersion is variance. So variance is mean square error with respect to A is minimum when A is arithmetic mean. It means the mean square error, if it is taken around the mean value, then this is called variance, right? So in our previous case, S square was 1 upon n summation of xi minus A capital A whole square. Okay, but if A is taken as mean, because this mean square error with respect to A is minimum when A is arithmetic mean of the data. It means if we put the value of A is equal to x bar, it means the mean square error taken around mean, arithmetic mean, then this is called variance, right? So variance is nothing, only the mean square error with respect to mean. This is the mean square error taken around the mean value, arithmetic mean. This is called variance. Now, what is the standard deviation? So this standard deviation is nothing, only the square root of variance. If we take the square root of variance, then it is called standard deviation, sigma square. If we take the square root, that is sigma, that is called standard deviation. Here we have the two notations, s square and s square for the sample. If we are taking the sample, then this is denoted by sample variance. If we are taking the population, then it is called sigma square, right? Then the square root of variance is called standard deviation. It hardly matters whether it is from sample or this population. So what is the advantage of this standard deviation? So this standard deviation or standard error has an advantage that it has the same units as of data. So it is easy to compare. For example, if x is in meter, then s square is in the meter square, which is not so convenient because it will be increased x square. But on the other hand, if x is in meter, then s or because this is not a square, because both are in the same unit, so meter square नहीं होगा. If x मीटर में है तो s स्क्वायर या सिग्मा स्क्वायर वो भी मीटर में नहीं होगा, मतलब because the unit will not change. Suppose x is any variable and its observation is centimeter. Okay, this is height. So height is in centimeter, 1.5, like 150 centimeter. Then s square or sigma square will be s square. It means x square. It will be in square centimeter square. So it will not easy to compare. So for that, to make it convenient, unit will be same. That's why this standard deviation is used, right? So variance or standard deviation measures how much the observations vary or how the data is concentrated around the arithmetic mean, right? So this is the use of this variance or standard deviation. So what is the difference between variance and standard deviation and why this standard deviation is used? instead of variance. I have explained here. So if any question, you can ask.
Thank you very much, sir, for very informative and very interactive session. Now, I would like to request all participants again, then if there is any query remaining, then you can simply write in the chat box or simply raise your hand, so I can send you the unmute request. Thank you, Dr. Prashant, Dr. Swati. If you have any query, then please write in the chat box. Thank you very much. Thank you for positive feedbacks. Thank you. Thank you. I hope all queries are answered and covered during the session. And tomorrow we have practical session. There are 2 practical sessions and delivered by Sir itself on using SPSS. Thank you. Thank you very much. Thank you. Thank you, Dr. Prashant, again.
Thank you. Thank you all the participants for patiently listening me. Thank you. Thank you
Thank you
all.
so much, sir, again for very informative and interactive session. Now, on the behalf of Institute of Applied Statistics and National Institute of Ayurveda, Jaipur, we convey our sincere thanks to all the participants for their active participation and commitment for today's session. We heartily thanks the guest speaker of the session, our respected Dr. Dharmendra Kumar Yadav, sir, who kept the participant engaged by the very informative and interactive session. And this is the end of today's session. Again, we meet at the same time. Last 2 sessions will be delivered at the same time, starting from 6:30 p.m. And both sessions are practical session, so please join 10 minutes earlier to avoid any technical issues. Thank you. This is the end of today's session. Thank you.